Various problems of finding out the nature and position of the image can be solved by using a relation between u, v and f. So here, what is u, v and f? Let this is our mirror. This is plane axis or main axis. This is pole. This is center of curvature. This is focus. If we plot a object, this is object, the line is goes like this, and this line goes like this. This goes strike back, this goes strike back. The image is formed here. This is our image. This is object. This is object. This is image. Okay. So distance between the mirror and the object is u. Distance between the image and mirror is v, and this is f, the distance of focus from the pole. Now here, if you want, you can draw this. In a spherical mirror, the distance of the object from the pole is called the object distance u. The distance of image from the pole of mirror is called the image distance. As we talked here, the distance of object from the pole is called u, object distance. V, image distance, distance of image from the pole, and the distance of focus from the pole is focus length. This is the formula. 1 upon f is equal to 1 upon v plus 1 upon u. Magnification. This is little important. It is the measurement of enrollment of the image with respect to the size of the object. Numerically, it is the ratio of image size to the size of the object. It is represented by m. Suppose this is a one size. This is a one size image. This is second size of image. If we make the ratio of both length, that could be called a magnification factor for these. This is like this. It is the measurement of enlargement of the image with respect to size of the object. Here you can see the we zoom and zoom out in the cameras. So what happened? We enlarged the frame rate. So it is the measurement of the enrollment of the image with respect to the size of the object. Numerically, it is the ratio of image side to be side of the object. It is represented by m. M is equal to h dash upon h is equal to I upon o minus u upon v upon u. H dot size of the height of the image, size of the height of the object. H dash is used for image and H for real object. I size of image, O size of object, V distance of image from the pole, and v u distance from the pole of object. Here you have to write down this formula. Here we will understand this. Magnification is a ratio of image size, so it has no unit. Yes, if there are two same parameter in ratio, so that thing is unitless, like length upon length. So what is unit of this ratio? None. No unit. Same. So magnification is a ratio of image size, so it has no unit. Here. We will talk this figure, first one, like coordinates. If there, this is x-axis, this is y-axis. For the value of x and y in this axis, x is positive, y is positive. In this axis, x is negative, y is positive. In this axis, x is negative and y is also negative. In this axis, x is positive and y is negative. Same here. All horizontal, you can see here, all horizontal distance in this direction are positive, right? In this direction, all the distance is positive. In this direction, all horizontal distance in the direction are negative from the mirror. If suppose we put a mirror here, it can be concave or convex. If we put a mirror here as a graphic fix, this side, this value for x and y is positive, this value for x negative and y positive. Same here, all vertical distance above principal axis are positive, all vertical distance below principal axis are downward. For concave mirror, this side is polished. So what happened? All the images formed this side, on the left side. In just one case, the image formed this side, that is this one. Here you can see images from this one side when the object placed behind the focus and uh, between the focus and pole, the images formed real virtual other side, or other cases, all 5 cases, images found in the left side. So here example of horizontal distance, object distance, image distance, focus distance, height of the object, height of the image. For concave mirror, for convex mirror, same, or horizontal distance in this direction are positive, in the direction are positive, in the direction are negative, in the direction positive, in this direction negative, same. Here there are some Sign convention for mirror rules. While attempting the numerical based problem of reflecting of light by a spherical mirror, we follow a set is known as New Christian sign convention. In this convention, the pole P of the mirror is taken as the original. The principal axis of the mirror is taken as the x-axis, x-z of the coordinate system. The convention are the follows. The object is always placed to the left of the mirror. This means that is the light coming from the object fall on the mirror from the left hand side. Means here in this figure, object is placed on the left side, this side. Object is placed at left side, so light will come from left, then the image is formed on lens. All the distance parallel to the principal axis are measured from the pole of the mirror. All the distance is measured from the pole. This is the pole. All the horizontal distance along the principal axis which are measured toward the right of the pole as taken as positive. All the horizontal distance which are measured toward the left of the pole as taken as negative. Vertical distances which are above the principal axis are taken as positive. Vertical distance which are below the principal axis are taken as negative. As we says, horizontal this side, horizontal is this right side positive, left side negative. Up above the principal axis, all the vertical positive, downward negative. We have to write down this 8 points. First to these points, then these 8 points. The focus of the convex mirror should be taken as negative. The focus length of the convex mirror should be taken as positive, because in concave mirror, here in concave mirror, the image is formed here and object is placed here. The light is coming from this side, so focus is in left, so it is taken as negative. Here the focus length is taken as positive because this is on the right side. Here concept very important for to the note of the solving numerical. A positive V is case of mirror means image is virtual. How? Concept very important to note for solving numerical. A positive V in case of mirror means image is virtual. V in case of mirror means image is virtual. Here, if V positive V image, if the image is formed here or here, so this is virtual. A negative V in case of mirror means image is real. V negative means left side. If the image is left side means image is real. U is always taking as negative in all cases. U. Distance of object is always taken as negative in all cases because the object is always placed in left side. So this is always negative. A positive image height shows that image is erect. Means erect, this image is erect. What is image is erect? Here, if the image is upward, this type, this is image erect, yeah, erect image. A negative image height shows that the image is inverted. If the height is positive means it is erect. If height is negative, image is inverted, means opposite, downward. A negative sign in the value here. Negative magnification, so inverted image if m is negative. It's so inverted magnification. Positive magnification, so erect image, the height of image should be taken as positive for virtual image, the height of image should be taken as negative for the real image. A negative sign in the value of magnification indicate that the image is real. Negative sign, yes, here if the value of v is negative means image is real. If positive, then this is virtual. Same, a negative sign in the value of magnification indicate the image is real. The negative sign, a positive sign in value of magnification indicate the image is virtual. If m is positive means image is virtual, m is negative means image is real. If magnification is less than 1, image is smaller than the object. If m is more than 1, the image is larger than the object. If value of m is less than 1, then the image is smaller. If the m is greater than 1, large image. M less than 1, small image. Now, refraction of light. We already covered this topic in previous videos. If the what is reflection? There are two things: reflection and refraction. Reflection. If the rays come here, as you can see here, the light rays coming and striking and it back, this is reflected. If the light ray come and go through the other medium, that is, and the angle of light is bent, it depend on the is the medium is rare or denser. Here, let me zoom in. Here, as you can see, light travel in a straight line, but when a light rays pass from one medium to another, which have different densities, its path get deviated. The deviation is called refraction. What is deviation? When here you can understand this. This is a plane. Light come and back. This is incident, this is reflected, this is normal to this plane. This is 90 degree, this is 90 degree, this is 90 degree, and this is also 90 degree. Light come and reflected, this is reflection. Here, this is plane, or this is better glass slab. The light is coming. पहले make a normal. Yeah, this light is coming, and this is the path of the light. But here the light get bent towards the normal. It's depend if here you can see here you can see glass is denser than air. In other word, air is rare medium while glass is denser medium. So when the light rays enter from air to glass, they bend toward the normal. Then light ray emerges out from the glass box. The medium again changes. Now light ray from glass denser move to rare, so it move away from the normal. Here, as you can see, this is an experiment. I will explain here. Suppose this is an experiment. Here we are going to take a glass slab, placed on the table, glass slab. Now we put two pins here, E, V. We put two pins here, A and B. The light is coming like this. Okay, this is our normal. Here, according to reflection of light, when light goes from rare to denser medium, it bends toward the normal, but we don't know that here. So what we do, we see from this side. This is a glass slab, these two pins. We see from here, and from the here we are seeing that two pins are placed like this and this. This light is coming. This light is coming. So what happened? Light get here in, emerge from here. This is the path of light, and this is the real path, and this is the emerge path. Both are the parallel. This and this one are the parallel. Here, this ray come, we put two pins here, A and B, C from the here and place two pins C and D here, and seems like the ray is coming like this. These pins are placed aligned with this line. We draw a line from here. We put two pins here C and D, then draw a line, then make this line B and this line. Here, as you can see in this figure, here he placed two pins E and F. We placed A and B here. Here we placed two pins E and B, C and D. This is glass slab, this is our light ray. This is normal, this is normal. Here in this figure, this is first pin, this is second pin, this is third pin, this is fourth pin. We have placed here. First pin E, F, and third for GH. This is a glass slab. As we talk about, the light rays coming from here, then here it strike here at this point. This is incident ray, so this is I1. This is reflecting ray, so this is R2. This one I1, this is R2, this is I2, this is R2, because for here this is a denser, this is a rare. So first what happened, when the light comes from rare to denser, the light moved toward the normal. When it comes from denser to rare, it move away from the normal. So this is moving from away. This line is going like here. Then we saw from here, we put those pins here, G and H. Then make a line here. Make the normal from the here. We can measure this angle and this angle, and we draw this line, and we can measure this angle and this angle, and from this we can see here this line and this line are parallel. This is the reflection. Here the heading is reflection through a rectangular glass slab. Take a rectangular glass slab and consider adjoining figure. Fix a sheet of white paper on the drawing board and place the rectangular glass slab over the sheet. Now draw the outline of the slab ABCD. This is glass slab. We draw a slab here. Take four identical pins and fix them vertically at E and F as shown in the adjoining figure. Look for the image of the pins E and F, the opposite of the glass slab, and fix remaining two pins G and H as shown in the figure on the straight line. We fix first E and F two pins, then G and H. Now remove the pins and the slab. Join the position of tip of the points E and F. Produce the line up to AB. Let EF meet at O. This is O. Position of tip pins G and H produces up to SCD. This is SCD. HG meet CD at O dash. Join O and O dash. Also produce EF up to P.